Hello and welcome once again to Quest, the weekly inter-school science quiz, which is brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. 2 new schools and a new quiz master today. But first, the introduction of the quiz master. It gives me great pleasure to welcome Mr. Anil Manekar, who is the director of National Science Centre, Delhi. Let's give a big hand. The 2 teams here today, on my right is the JC Bose team, that's the team from Techno Model School, and you are?
Hi, I am Atanu Mukherjee and I am studying in class 12.
All right, and you?
Hi, I am Shubhashisha, I am also studying in class 12.
Hi, I am Olkananda Kaur and studying in class 12.
Well, happy quizzing. And on my left, the CV Raman team is the team from Haryana Vidya Mandir, and you are?
Hi, I am Divya Patodia and I study in standard 12.
Hi, I am Abhishek Goel. I study in standard 11.
I am Devraj Larry of standard 12.
Are you all confident of winning today?
Yeah.
Sure.
Okay, let me wish both the teams all the very best. The rules of the contest, fairly simple, pretty much the same as every week. The first 4 questions are direct, 20 points for the correct answer, 10 on passes, approximately 15 seconds to answer your direct questions. More about the rounds on the buzzer when we get to them. So the very first question of today's episode of Quest is for the team on my right, that's the JC Bose team.
Let's play a little toy here. I have a small toy here. Are you able to see this?
Yeah.
Have you seen it earlier?
No.
No, okay, that's good. See, there is a metallic frame all around and there is a wheel in the center. Are you able to see this wheel?
Yeah.
And it's free to spin. Okay? And I have tied a string on this axis so that I can pull it and set this wheel in the motion. I will do that. But before that, I want to see whether this toy is balancing on any of the object. Let me put it here. Does it? No, it falls off. Okay. So no question of balancing it in this one or this one. Now let us see what happens when I spin this central wheel. Okay. Now I place it on my hand. Can you see it? Isn't it amazing? Now the question is, what is happening here? When the wheel is not in motion, it does not balance. When the wheel is in motion, why does it stand the way I want it? I can place it this way, I can place it this way, I can place it this way on the table, I can place it on this small string, it balances. So what is the science in this?
Center of gravity. First
Five seconds to go, please hurry up.
When the wheel is not in motion, so it's falling. But when the wheel is rotating, a force is acting on the wheel. As a result, the centrifugal force is acting outwards and the wheel is rotating. So the center of mass is directed and so it doesn't fall. As the force is acting outwards, which is setting the wheel in
center
motion.
of gravity is balancing the wheel.
But if I place it this way also, it balances.
Yeah, because it's moving, the force is acting outwards, which is balancing it.
Which way? This way or this way?
That way. And the direction in which the wheel is moving.
Okay. Okay, I will tell you the reason.
No, just a moment. I think this must go over to the other team here.
Okay.
Mr. Manekar?
Yeah.
Yes? Haryana Vidya Mandir?
Force is acting radially outwards.
Radially outwards.
The centrifugal force. Yeah.
Radially outwards.
Are you sure?
Yeah.
Just
Is that the right answer, Mr. Manekar?
I don't think so.
I guess
Of
this
course, there is some force acting on this,
Yes.
but I will have to correct what exactly is happening.
will, in that case, Mr. Manekar, this goes over into the audience. Any takers in the audience? Nobody? I guess this is the quiz master's question, Mr. Manekar. Right, why don't you give us a better explanation?
Okay. Do you know what is it called as? This is called as a gyroscope. You might have heard this term. Okay. What's happening when I spin this wheel? The spinning wheel has a momentum associated with that. You might have heard this momentum. The momentum is what? It's nothing but the product of mass
Velocity.
and the velocity. In this case, it is the angular velocity. Now, because of this momentum, this wheel has a tendency or rather a force acting on its axle in such a direction that it will try to maintain its position whatever it is. If I have the position this way, it will oppose any change in the direction whatever takes place. If it is this way, the force will oppose any other direction change. That means this gyroscopic wheel opposes any change in the direction of its central axis, and that is the basic reason this wheel can be balanced either on this string, it can be balanced on this one, it can be balanced on the table, it can be balanced even on the tip of a pencil. So, it is an amazing toy.
Well, great question then, Mr. Manikar. Welcome back. You're watching Quest, the weekly science quiz for students studying in classes 11 and 12 in Kolkata city. As you know, this quiz has got a thrust basically on education rather than competition. But then, since we have two teams here, let's wish both teams all the very best. Next question, CV Raman team. Mr. Manikar.
Are you able to see a small device I have brought in here? Okay. You can see that there is a central shaft, and then there is a stick or another small shaft which is attached at an angle. And now there is another vertical sheet here which is made of the clear acrylic, and there is some curved line in that. I am going to switch on the power to this device and let us see what happens. You can watch it carefully, see that a stick which is a straight line which is smoothly passing through this curved groove. Are you able to see that?
Yeah.
Have you seen it? Okay. Is it amazing? Okay. Now the question is, what is the science here? What exactly is happening? Can you explain that to me?
I think it's the magnetic effect of current working here. So, and the needle is being deflected due to the magnetic effect of the current. And the field lines are within those two curved lines. So
And
it's
so
not
it's
going
curving
away from
the
curved lines.
You feel that?
No, I'm afraid, Debra, that's not the right answer. Yes?
Actually,
Jesse
a part
Boston.
of stick is entering the curve a part of time.
Yes.
In fact, for this, so there is no striking up with the glass, and so the stick is coming out smoothly.
Yeah. But give me something more. I need something more. You are right on the track. It's a simple phenomena.
And due to the motion, the slow motion.
Of course, that's there.
Subhashish, nothing to add to that?
And the
Somebody?
angle of inclination
Atanu?
of the shaft.
No, the angle is made in that way, so that the string should pass, so that the line should pass.
That's true. Are you able to say anything more in this one?
I guess not. Audience, anyone? Well, back to you again, Mr. Manikar. All right.
All right. No, I just asked a simple phenomena. There is nothing magnetic field or anything in this place. What's happening? There is a shaft which is revolving around, and there is a straight line which is attached to this central shaft. Now this stick, when it is revolving around, it will generate a surface of revolution. You know that?
Yes.
And what will be the shape of this surface of revolution?
It's a circle.
Circle.
No,
Each point will be a circle.
Absolutely.
Every point on this stick will be generating a circle. But what will be the diameters of these circles? The top portion of the circle will be bigger, diameter will be big, then it will be small, then again reducing, then gradually reducing, coming to the minimum, then again increasing.
it's a
What's the shape called as now?
hyperbola.
It's a hyperbola. And that's what I was really expecting. It's a hyperbola, and you might have seen that this stick is passing through that because the surface of revolution of this stick is a hyperboloid shape, and when I cut it in the center, it's a hyperbola.
Welcome back. Both teams yet to get off the mark. Next question, Jesse Bose team. Mr. Manikar.
Well, now it's a simple experiment here. Are you able to see a small projector here? So what does the projector do?
Show slides.
It's a source of light, and for all practical purposes we we can assume that it's a source of white light.
White light.
Okay, and you all know white light is a mixture of
7 colors.
seven colors. So we assume that there are 7 colors coming out of this project. Okay. Now I have a piece of plastic, or we call it as an acrylic. It's a transparent. What the color of this one?
Blue.
Blue. I hold it here and see what happens to the color. Can we please have a white paper here?
Oh, you want me to hold up something,
Please.
Mr. Manika?
Yeah.
All right.
Thank you. So initially
teams?
it's white,
Yeah.
right?
What teams can you see?
Can you see that?
Excuse me, we can't see.
Excuse me.
We can't see.
You can't see it? Are you able to see the blue color now?
Yeah, yeah,
Can you see that?
yeah.
Okay, we can hold it closer so it will be brighter.
Okay, here we go.
Okay. Okay, so when I hold a blue piece, I am getting a blue light. Now I have another piece, I have a yellow piece.
Yellow.
Okay, let me see what happens with yellow. So what's happening?
Yellow.
I am getting yellow light now. Now what will happen, let us see when I hold both of them together. I have a blue and a yellow. Can you see what's happening?
It's green.
It's green. Okay. I have nothing green. I have a blue and a yellow. The question is, where from are we getting this green color? You can tell me what is really happening also in simple words.
Actually, when we are putting the blue color, we are getting a blue light, and when yellow, we are getting a yellow light. But
Okay.
when both are keeping the mixture of blue and yellow, we are getting a green color.
Okay, you are in the right direction. But
If you mix blue and yellow together,
We get green
we
color.
always get
Green color.
Green color.
we'll get green color.
Yeah.
Okay, let me see what your other team also is saying.
The green.
1 minute.
I think in all fairness, Mr. Manika,
Yeah.
Subhashish, what you really need to do is, you got to explain how is it or why is it that when you put a blue and a yellow slide together, we get a green. Why?
So the wavelength of the yellow color and the wavelength of the blue color is mixing up and just producing the wavelength of the green color
You mean to say they are getting added together
added together and giving a
producing
green
green
color
and you are getting a green color.
colored with.
Is that the answer you're looking for, Mr. Manika?
Let me see what's this.
I
other
guess
team
not,
say.
Alokananda. Yes?
Green color, the wavelength of the green color is intermediate between blue and yellow.
And that's
When you are mixing the two, it's not neither blue nor yellow. We are getting the intermediate of that, which is being reflected by the white sheet. That's why it's green.
because of the overlapping.
Because of the overlap.
Of the two waves.
Okay, I think I should consider this little bit closer to the answer. Okay, so let's give them a bonus points, whatever.
Divya, I think you stumbled on the answer by kind of deducing and by not trying to make the mistakes that the other teams did and your own team members did, right?
Yeah.
But I don't think that was the real explanation that Mr. Manika was looking for. Yes, Mr.
Yeah,
Manika?
yeah. When I pass a light through any such kind of, say, piece or slide, what is really happening?
The
All the
color of that which is made, the color of this flame,
See, I am getting 7 colors out,
yeah.
but
When
by
you put-
placing this I am getting only one
the
color out.
blue sheet is allowing only the blue light to pass through.
That's right, that's right. What is this? This is a filter. It filters out all other colors except blue. Okay, but this is not a true filter. So what it does, it also allows some adjacent colors. So which are the adjacent colors of blue?
Green and yellow.
Indigo? No, both sides. If you consider Vibgyor,
Yes.
indigo and green. So this is allowing indigo, blue and green, though we are not able to see much. Okay. Now this one also is not a pure filter. It allows yellow, which is the central color, and the two adjacent colors. Which are the two adjacent colors for this?
Orange and red.
Orange.
Orange and
Orange and green.
Green.
So which is the common color?
Green.
Green is the common color. So only green is able to come out, and that's why we see green. Yeah. See, I have a beautiful pattern drawn here. Can you see that?
Yeah.
Okay. What is this? There are some lines originating from a single point, and they are going out, okay, in all the directions, and they are bulging in size. Now, I have another pattern exactly same one, in fact, the Xerox copy of the photocopy of this same one. Okay? It is on the transparent sheet. Now, let me overlap these two together and see what happens. Can you see what is happening now? Are you feeling some changing shapes are there? They look like what?
Spirals.
They are looking like spirals or magnetic lines of force?
Yes.
Is it? Of course, there is no magnet here, I am telling that. Okay. So, now I think you might have seen this in some books or maybe in some science centers or science museums. Now, can you remember what it is and why it is happening?
कैमरा
5 seconds to go.
So here we are saying that when the light is falling on the white sheet,
Okay.
white portions, then the light is getting reflected back, and again in the transparent sheet, when it is falling on the transparent sheet, some of the part of the light is obstructed by the black lines, and for that reason this thing is happening.
Yeah, you want to add something? You are telling something?
black sheets and the light is absorbed by the black portions
Okay.
of the white sheet.
Do you know the name of this this pattern? You have read somewhere?
No, actually, we don't
Something
remember.
starting from M. I am giving you the clue. I am sure it is available in Calcutta. This thing are seen in Calcutta, maybe in some of the science centers here. Have you heard the word Moire patterns? Yes. You all knew that. This is called Moire pattern. Okay, what is happening here? There is nothing with black or this, that what you are telling, but of course I can do it with two transparent sheets also and then project it with the help of a projector. What is happening here? The two similar patterns, when they are overlapped, there is an interference pattern emerging out. What happens is the interference of these two designs takes place, and this interference, they are basically addition of two waves of the light, and it results into the constructive addition and then constructive subtraction. So, where it adds constructively, you get blackish portion, and where it subtracts, you get
gets the
whitish
whitish
portion. So, this is basically the interference pattern of this design, which is called as the Moire pattern, and that is the very important property it proves about the light. It says that, it proves rather that light is a waveform.
Scores at this stage read 10 points to the C.V. Raman team and J.C. Bose team yet to score. The rules of the next round: the next question is on the buzzer, as are the next two. Remember, both teams, when you hit that buzzer, you should be ready with the answer irrespective of whether or not the question has been asked. All right? So you must have an answer ready. Mr. Manikar will then cease to do whatever he was doing or asking the question that he was going to ask you. All right? It's plus 20 if you get it right, and it's minus 10 if you do not get it right. And these questions will not pass over to the other team, they will go straight into the audience. So, Mr. Manikar, if you are ready,
Yes.
here's the next question.
Two balloons lying here, okay, and you know the relation of balloons and the needle? Yes?
I can't look.
Okay. Should we burst the balloon? Yeah. Okay. Let's try to burst it.
Is this balloon made of the normal stuff?
It's a standard balloon available in the market.
Standard balloon. Not a scientific balloon, Mr. Manikar?
Not a scientific balloon.
Not a scientific balloon.
It's not bursting.
Let me try.
Yeah, sure.
Quick.
What's this? How does it happen?
Is
It's
this
a normal balloon which is available in the market, and here's pierced needle in it. Okay. So how is this? It's a strange phenomenon, isn't it? If I try to, let us see with the other one, bursts. If he does it, it pierces it. So, what is happening here? The question is why it did not burst earlier and why it is bursting now.
So are they equally inflated?
Almost, almost. They are almost equally inflated.
Okay teams, time is running out. We got about less than 10 seconds to go now. Well, neither team daring enough to go for the buzzer. Anyone in the audience with an answer? Yes? Why don't you come up? We saw you. You are?
Standard. I just.
What's your name?
Piyush Bhutodia.
Yes, Piyush.
Standard 12, Haryana Vidya Mandir.
Yes, Piyush.
Actually, the balloons are not completely filled. So from the upper part, they have from some parts they have stretched completely, and from some parts there still has some capacity to expand. So here it is not expanded completely. So here, if we pierce the pin, then it is not bursting. But here, if we pierce it, the balloon is bursting.
He's right. He's right.
Well, Piyush, you have the right answer then. Would you like to add to that, Mr. Manikar?
Yeah. What happens when we inflate a balloon? What happens? The skin of the balloon gets under tension only in the side part. The front portion and the portion near its opening, mouth, they are not under tension. These portions are not under tension. So one can gradually pierce a pin in that. Okay. Even if I inflate it little bit bigger, it does not matter, because the portion here will not be under that much tension as the portion here it is. So he said that.
Would that mean, Mr. Manikar, that the balloons are in less tension than both the teams for not scoring points? I don't think so. Well, Piyush, we have a small memento for you from Quest.
Thank you.
Great answer. You can go back. Well done.
Okay, let us do a simple experiment now. You all know a standard water bottle, okay? It is not doctored, nothing has been done here, and it is empty, but it contains something. What is that?
Yeah.
Oh, that is great. Now let us take a piece of paper and try to put it in. Okay? Take on a piece of paper, place it here. I will blow air. Have you seen what happened?
Yeah.
The piece of paper, instead of going inside, it was ejected out. You want me to do it again? What is happening here? The question is, what is happening here?
We are giving the force to it, but
Or you can tell me the name of the effect used, the principle.
Yes, Subhashish?
Actually, the bottle is filled up with air.
Okay.
When we are putting the paper near the mouth and we are blowing it, the air pressure inside the bottle is preventing the paper to enter inside, and hence the paper is falling off.
Okay, they are very close to the answer.
So again, so the air which we are blowing, that some part of the air is entering the bottle and the air pressure in the bottle is increasing, and that is thrusting the paper to come out.
That's right. That's right.
Great answer. Well done. In a battle which is seeming to warm up in the fag end, scores now look different. JC Bose's team now the leaders at 20 points, CV Raman on 10, and the last question also on the buzzer.
Simple black box made in my laboratory. Now I have a lamp inside, and there is a lens. I will be showing you exactly what is inside. And what happens when there is a lamp at the focus and there is a lens? I get an image of the filament. Okay. Now I will show the image of the filament here.
Turn it around.
Have you seen the filament? Is there?
JC
You can
Bose?
see the shape of the filament, right?
I think we'll keep it right in the middle.
Okay.
What teams can you see? Right.
All right. Now I am going to do, I have a small magnet with me. Okay. Now please believe me, I am not going to touch this magnet to the lamp. I am just taking this magnet near the lamp. Okay? I will not be touching it. If by mistake I touch it, I will remove it and I will do it, and I will do it again. Okay? Now see what happens to the filament. Can you all see that? What do you see?
We can't see it.
I think we'll turn it around one by one for both
All
teams.
right. Let's turn it one by one. Let's see. This team let them see first.
Don't press the buzzers yet.
Don't press the buzzer yet. Are you seeing the filament? Do you see anything?
Can you see it moving? Yeah. All right.
Okay. It's shimmering, shivering. Do you see the filament now?
Yeah.
Okay. Okay.
Shivering.
It's shivering. Let's do it again once again. Okay. The filament is shivering. It's vibrating. Now the question is, why does it shiver or why does it vibrate? The simple.
Abhishek.
It's because of the magnetic field. You have placed a magnet and they are bound to be a deflection of the conductor which is carrying the current. That's why it's shivering.
Exactly. You said right. So let's give them a big hand for the correct answer. Can you add little bit to this? The answer is right. The answer is right. Can you add little bit here?
It's made of tungsten, that wire, so it's only if the conductor is there, then only there can be the magnetic field.
Yeah, and it can tungsten a magnetic material?
Yeah.
Well, you've got the point, nothing to lose, you can say whatever you like.
Okay.
Yes, Mr. Manekan.
There is a filament which is a current carrying conductor. Okay. So when it's carrying current, there is a magnetic field around this conductor, right? And when I bring another magnetic field near that, what happens?
So there is
These two magnetic fields will interact with each other. Now which kind of current is flowing through this filament?
it's AC.
It's an alternating current. Okay. So the magnetic field around this filament is also alternating. It's changing its position, direction. Okay. How many times? 50 times in a second.
Yeah.
Okay. And because of that changing magnetic field and the interaction of that changing magnetic field with the steady magnetic field, the filament tries to go away from the magnet, tries to come close to the magnet, tries to go away and come close. And that's why it's shivering. Okay. So
Well, C.V. Raman team, brilliant answer then. And you pick up 20 points. Your final tally goes up to 30 points and the JC Bose team finishes with 20. Well done both teams. We thank you for being on our show. Let's have a big round of applause for the winners today. That's the C.V. Raman team. Well done Vidya, Abhishek and Devraj. Well, not wanting to take risks there, I thought Alokananda. You were doing quite well till one time. Thank you for being on our show. Please sit down. Well done, Subhashish and Othello. We hope you enjoyed watching our show. We'll be back next week again at the same time with 2 new schools, that's 6 new faces. Please do write back with your comments. Our address is Quest, care of Doordarshan Kendra, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week. Till then, it's goodbye from all of us at the production team here at Doordarshan.